Good morning dear students. In your previous video class, you learnt about molecular mass and formula unit mass. And you also learnt about how to calculate the molecular mass of a compound and formula unit mass of a compound. Children, in this class, we will discuss about mole and mole concept. Okay, now let us going to understand mole concept through this example. Look at children. See, here the hydrogen is react with the oxygen. It gives the water. Now, explain this reaction through the number of molecules react in this equation. Yes, look at here. 2 molecules of hydrogen reacts with 1 molecule of oxygen. It gives 2 molecules of water. This is in terms of number. Now, let us explain this reaction according to their mass, atomic mass unit. See now here, 4 atomic mass of the hydrogen reacts with 32 atomic mass of the oxygen. It gives 36 atomic mass of the water. 36 atomic mass of the water. Look at children here, the representation of the equation. In equation, this equation shows the number of molecules involved in this reaction. It is more convenient rather than expressed in their mass. Is it or not, children? Yes. The representation of the equation in terms of how much the molecule or atoms involved in the reaction, that is more convenient rather than we compare it to the mass. For this reason, the new quantity of representing the molecule of a compound is mole. Is taken as mole. Mole is a number. Mole is a unit that contains and that represent the number of atoms in that. Look at now, mole. Mole is defined as like this: 1 mole of any species. Children, observe here, any species. It means it may be an atom or a molecule or a ion. Species is the quantity in number having a mass equal to its atomic or molecular mass in grams. Look at here, 1 mole of any species, it contains this much of atoms, 6.022 into 10 to the power of 23 atoms. And I told you already, the 1 mole is always equal to its relative atomic mass. When we introduce the mole concept to that formula unit, that means atomic mass unit gets changed into grams. Look at here, 1 atomic mass unit of hydrogen, it is equal to 1 atom of the hydrogen. And when we introduce the mole, yes, that is converted as gram. 1 gram of hydrogen is equal to 1 gram. 1 U is equal to nothing but 1 gram of hydrogen. That 1 gram of hydrogen contains 1 mole of atoms of the hydrogen. This mole concept is also named as Avogadro number. That Avogadro number is represented by NO. Avogadro number is represented by the symbol NO. The 1 mole number is like this. This is very important for your exam point of view. And look at children here. 1 gram of hydrogen is equal to 1 mole of atoms of hydrogen. This 1 mole of hydrogen contains 6.022 into 10 to the power of 23 atoms of hydrogen. As this is obtained from experimentally proved after it is taken as a mole. And now let us understand this mole concept by taking another one example here, children. See now, 16 U of oxygen. We know that oxygen atomic mass is 16 U. Oxygen molecule atomic mass is 16 U. And shows one atom of oxygen. It shows one atom of the oxygen, and here when introduced into the mole, it is considered as 16 gram of oxygen is equal to it contains, and it is referred 16 gram of oxygen is refers 1 mole of atoms of oxygen, and this 16 gram of oxygen contains 6.022 into 10 to the power of 23 atoms of oxygen. And like this, we have to take the mole when we compare with the relative atomic mass of any element or atom or molecule of the compound. All of you take this, children, now. Okay, children, now come to in-text question. These questions are related to molecular mass and formula unit mass. Okay, now come to the question. Calculate the molecular masses of the following. The first one is hydrogen molecule. Yes, molecular mass of hydrogen molecule. See, children, here this 2 indicates it contains 2 atoms of hydrogen. That's why E is equal to 2 into H. Yes, we know that, children, the atomic mass of this hydrogen is 1U. Atomic mass of hydrogen is 1U. Write here that 2 into 1 become 2U. This is a molecular mass of hydrogen. Molecular mass of hydrogen. The next is molecular mass of oxygen. See, children, here also this 2 indicates it contains 2 atoms of oxygen. Yes, now 2 into O. We know that, children, the oxygen atomic mass is 16U. Now substitute here that 2 into 16 become 32U. Now let us going to calculate molecular mass of chlorine. See, children, here also this chlorine, this 2 indicates is having 2 molecules of chlorine, 2 into Cl. And the atomic mass of chlorine is 35.5U. Now substitute here 2 into 35.5. Yes, multiply these two, that gives 71U. Next, we go to molecular mass of CH4. Molecular mass of CH4. This is a methane. See, children, here it contains 2 atoms. One is carbon, another one is hydrogen. 2 kinds of elements. And this here one carbon atom is there, plus with that 4 atoms of hydrogen. 4 atoms of hydrogen. Children, see here we know that the atomic mass of carbon is 12. Put here that, and atomic mass of hydrogen is how much? Only 1. Yes, 12 into 1 become 12, plus 4 into 1 become 4. Now 12 plus 4 become 16U. This is a molecular mass of methane. Next, we go to molecular mass of C2H6. Look at, children, here. Here this formula indicates it contains 2 atoms of carbon, plus here it indicates it contains 6 atoms of hydrogen. Now substitute the atomic masses of carbon and hydrogen. Atomic mass of carbon is 12 and atomic mass of hydrogen is how much? 1. Now substitute here and multiply. 12 2s are how much? 24, plus 6 1s are 6. Yes, add these two now. Yes, we get 30U. This is a molecular mass of C2H6. Yes, children. Now come to molecular mass of C2H4. Yes, this formula shows this molecule contains 2 atoms of carbon plus 4 atoms of hydrogen. Now substitute atomic masses of carbon and hydrogen here. Now 2 into 12 plus 4 into 1. Look at children here. Multiply these two now. 12 into 2 become 24 plus 4 ones are 4. 24 plus 4 become 28U. This is a molecular mass of C2H4. Yes, now come to children, molecular mass of NH3. Yes, this formula shows it contains only one atom of nitrogen plus it contains 3 atoms of hydrogen. 3 into H. Now substitute atomic masses of nitrogen and hydrogen. Yes, atomic mass of nitrogen is how much? 14. And atomic mass of hydrogen is 1. Now 14 ones are 14 plus 3 ones are 3. 14 plus 3 become 17U. This is a molecular mass of NH3. Now let's go to molecular mass of CH3OH. CH3OH. Yes, this formula indicates it contains one atom of carbon plus it shows it contains 3 atoms of hydrogen, and this is shows it contains one atom of oxygen plus it contains again one atom of hydrogen. Now substitute atomic masses of each of the element. Is 1 into 12 plus 3 into 1 plus 1 into 16. See children, this is not 0. This indicates O. Oxygen atomic mass is how much? 16 plus 1 into 1. 12 ones are 12 plus 3 ones are 3 plus 16 ones are 16 plus 1 into 1, 1. Add all these. Yes, it become how much? 3 plus 1, 4. 4 plus 16, 20. 20 plus 30, 12 become 32U. This is a molecular mass of CH3OH. Okay children, now come to second question. The second question is like this. Calculate the formula unit masses of zinc oxide. See children, the name of this chemical compound is zinc oxide. This is sodium oxide. This is potassium carbonate. And the atomic masses are given here. Zinc atomic mass is like this, and sodium is like this, carbon is like this, oxygen is like this. Now let us use these given information and calculate the formula unit mass of the followings. Yes, now let us take first zinc oxide. See children, this shows it contains one atom of zinc plus one atom of oxygen. One atom of oxygen. Yes, 1 into zinc here how much? 65. Plus 1 into oxygen is having how much of atomic mass? 16U. Now let us multiply. 65 into 1, 65. Plus 16 into 1, 16. Add these two now. 5 plus 6 become 11. 1 carry. 1 plus 6, 7. 7 plus 1, 8. 18U. This is a formula unit of zinc oxide. 81U. Yes children, now come to sodium oxide. Yes, look at here. This chemical symbol indicates it contains 2 atoms of sodium plus 1 atom of oxygen. Now 2 into sodium is having how much atomic mass? Yes, 23. Plus oxygen is having how much? Yes, 16. Now multiply these two. 23 twos are how much? 46. plus 16 ones are 16. Add these two now. Yes, 6 plus 6 become 12. 1 carry. 1 plus 4, 5. 5 plus 1, 6. 62 U. This is a formula unit of sodium oxide. Now let's go to formula unit mass of potassium carbonate. Look at children this chemical symbol and write now. Yes, it contains 2 atoms of potassium plus 1 atom of carbon plus and 3 atoms of oxygen. Now substitute atomic masses of each one. Yes, potassium is having how much? Yes, here the potassium atomic mass is 39 plus carbon atomic mass is how much? 12 plus oxygen atomic mass is how much here? 16. Now multiply these two. 39 twos are how much? Yes, 78 plus 12 ones are 12 plus 16 threes are. 16 threes are how much? 48. Now add all these. Add now here 12 plus 48 become 60. 60 plus 78 become 60 plus 78 become 138 U. This is a formula unit mass of potassium carbonate. Okay children, now come to some example questions are given in your textbook and these examples are related to molecular mass and mole concept. Yes children, you have already know about mass of 1 mole and the mole indicates what? The mass of 1 mole of a substance is equal to its relative atomic mass or molecular mass in grams. Yes, clearly we know that 1 mole is equal to 6.022 into 10 to the power of 23 and this is also known as Avogadro number. Avogadro number, that Avogadro number is represented by NO and we know that children 1 mole of anything is always equal to 6.022 into 10 to the power of 23 atoms. Now let's go to solve some problems which are related to mole. Yes, look at children here. The example 1 problem is like this. Calculate the number of moles for the following. Yes, 52 gram of helium. Here what is asking? Calculate the number of moles for following. Children, we know that 1 mole contains 6.022 into 10 to the power of 23 atoms of that element. And here we have to calculate how much number of moles present in 52 gram of helium. And second question is 12.044 into 10 to the power of 23 number of helium atoms. In first case also we find the mole number. In second case also we find the mole number. Yes, now let us take the number of moles as small letter n. The given mass that is taken as small m. Molar mass is big letter M. Given number of particles that is taken as capital N. Avogadro number we know that children that is taken as NO. Now let's going to calculate moles of the first one. Atomic mass of helium. See children, atomic mass of helium is 4U. Molar mass of helium is 4 gram. Children, I told you already, the molar mass is always related to their atomic mass. Only one thing is changed here. We use U in case of atomic mass unit. but in case of molar mass, we use gram. We use gram. We take or we consider the number as it is, but we have to change the unit of representation. Now come to the number of moles. Number of moles is equal to the given mass divided by the molar mass. Given mass is small letter m, the molar mass is big letter M. See now children, this given mass is, in our first question, 52 gram of helium is given. That is a given mass. Right here 52. Molar mass of this helium is how much? 4. Now take that here. Now cancelled, we get the answer 13. Yes, the number of moles are 13. In 52 gram of helium contains 13 moles. 13 moles of atoms. Okay children, 52 gram of helium contains how much moles of atoms are there? 13 moles of atoms. Now come to the second question. The second one is 12.044 into 10 to the power of 23. Number of helium atoms, it shows how much mole. Yes. 1 mole is equal to like this. The number of moles is equal to given number of particles divided by Avogadro number. In such cases, here the mass is given in terms of number, you know. In such cases, we take the ratio like this. Given number of particles divided by the Avogadro number. But we compare with the first one, the mass of the compound is given in terms of the gram, you know. In terms of gram. In such cases, we take given mass to the molar mass. We compare given mass with molar mass in such case, but in case of number of particles, we take Avogadro number, n by n. Observe here children, the given number of particles are like this. The Avogadro number is like this. Both are cancelled together now like this. We get the number of moles are 2. Number of moles are 2. Now come to second example. Calculate the mass of the following. See children here, what is asking here? Mass is asking here. The problem is given in terms of the moles and given in terms of number of atoms. Now let us going to calculate mass of the followings. Yes, mass is taken as like this, molar mass into number of moles. Yes, mass is taken as small letter m is equal to m into n. Yes, molar mass of the nitrogen gas. Yes, we know that children, N2 is a molecule. Yes, it contains 2 atoms of nitrogen. N into 2 into 4 2 into 14 become 28. This is a molar mass of the nitrogen molecule. Now substitute that here. Molar mass is 28. The given number of moles is here 0.5. Multiply these two become, yes, it become 14 gram. This is a mass of the N2 gas, nitrogen gas. Now come to the second. Yes, in second case also, what is given here? Moles, 0.5 mole of nitrogen atom is given here. Yes, mass is equal to molar mass into number of moles. Mass is equal to, yes, molar mass of nitrogen is 14. Yes, we know that. Molar mass of nitrogen is 14 and the number of moles here 0.5. Multiply these two, we get 7 gram. This is a mass of nitrogen atom in 0.5 moles of nitrogen atom. Now come to the third. Third one is, what is given here? The particle numbers are given here. 3.011 into 10 to the power of 23 number of atoms of nitrogen. Now let us calculate mass of the nitrogen atom. Number of moles is taken as n. N is equal to given number of particles by Avogadro number. Yes, given number is 3.011 to 10 to the power of 23 by 10 to the power of 23. Both are get cancelled, and these two are cancelled like this. It gives how? It gives 1 by 2, that is nothing but 0.5 grams. 0.5 grams of nitrogen atom. And here the number of mass is equal to m into n. Yes, 0.5 gram is a number of moles. It contains only like that, and the mass of the nitrogen is 14, you know. Yes, that is multiply with the 14. 14 into 0.5 gives 7 grams. Totally here mass of nitrogen atom in mass of nitrogen atom in 3.011 into 10 to the power of 23 number of n atoms contains 7 gram of mass. It contains 7 gram of mass. Now come to fourth one. See children here. Yes. N is equal to the given number divided by the Avogadro number. Given number is 6.022 into 10 to the power of 23. The given the Avogadro number is 6.022 into 10 to the power of 23. Both are cancelled together. We get 1 gram. 1 gram. But we know that children, here the given molecule is N2. Given molecule is N2 because of that reason. It contains 2 atoms of nitrogen. One atom weigh 14 U. 14 into 2 become how much? 28. This is a molar mass of the nitrogen molecule. Now substitute here. Molar mass of nitrogen is 28 and the given number 6.022 into 10 to the power of 23 number of nitrogen molecule is having the mass 1 gram. Yes, 1 into 28 it gives 28 grams. Now therefore 6.022 into 10 to the power of 23 number of nitrogen molecule is having the mass 28. Is having the mass how much? 28 grams. Now come to the last example problem. Yes, see now what is asking here. Calculate the number of particles in each of the following. Now let's go to calculate the number of particles. See now first one, 46 gram of sodium atoms. Second is 8 gram of oxygen molecule, 0.1 mole of carbon atoms. Look at children here. In first case atoms are given here. In second case molecule. In third case the mass is given in terms of mole. Now let's going to calculate for all these two number of particles. Yes, solution. Number of atoms is equal to given mass divided by the molar mass into Avogadro number. It gives number of atoms. Yes, in first one, the given mass is there, you know, that is 46. The given mass is 46 grams divided by molar mass of sodium. We know that children, molar mass of sodium is 23. Now substitute that here. And Avogadro number, we know that Avogadro number is 6.022 into 10 to the power of 23. Yes, look at here, 23 ones are, 23 twos are, and 2 into 6.022 into 10 to the power of 23. Both are multiplied together, we get here 12.044 into 10 to the power of 22. 22 here. Yes, both are multiplied. We get here 12.022 into 044 into 10 to the power of 23. This is a number of particles present in 46 grams of nitrogen atom. And next we come to second question. Second, 8 grams of oxygen molecule. The number of molecules is equal to, observe here, given mass by molar mass into Avogadro number. The given mass is 8 gram. Molecular mass become how much here? 32 grams, because oxygen is have the molecule 2 into oxygen, 2 into 16 become how much? 32. Now substitute here that 8 by 32 into 6.022 into 10 to the power of 23 is both are cancelled together and multiply. It gives 1.505 in 5055 into 10 to the power of 23, and this is nearest to 1.51 into 10 to the power of 23 particles or atoms. Now come to third one. Yes, the number of particles or atoms is equal to number of moles of particles into Avogadro number. See children, here in our third question, the given mass is in terms of mole, 0.1 mole of carbon atom. Is due to that reason, now let us going to calculate the number of particles is like this. Number of particles is equal to number of moles of particles into Avogadro number. Here don't take the ratio. Here we take the given number of particles into Avogadro number. Clear that children? Yes. Now 0.1 into 6.022 into 10 to the power of 23, and both are multiplied together and we get here 6.022 into 10 to the power of 22 atoms. 22 atoms. Okay children, now come to in-text question. These questions are related to mole concept. Now let's see what he is asking here. If 1 mole of carbon atoms weighs 12 gram, what is the mass of 1 atom of carbon? 1 mole of carbon atoms weighs 12 gram. What is the mass of 1 atom of carbon? Yes, come to the solution now children. 1 mole of carbon weighs 12 gram. 1 mole of carbon atoms is equal to 6.022 into 10 to the power of 23. Yes, 1 mole of carbon contains this much of atoms. Now, molecular mass of carbon atom is equal to 12 gram is equal to an atom of carbon mass. Look at children. Yes, we know that the atomic mass unit is taken as a molar mass. In that time, we changed 12U into 12 gram. Hence, 1 mass of 1 carbon atom is equal to 12 divided by 6 in 12 divided by 6.022 into 10 to the power of 23. Yes children, it is gives 1.99 into 10 to the power of 23 minus 23 grams. This is a mass of 1 atom of carbon. This is a mass of 1 carbon atom. 1 carbon atom. Yes, listen once again. 1 mole of carbon weighs 12 gram. 1 mole of carbon atoms are here like this. The 1 gram of carbon contains 1 mole mass of carbon contains 12 gram. Yes, in that 12 gram, it contains 6.022 into 10 to the power of 23 times of carbon atoms. So, mass of 1 carbon atom weighs like this. 12 divided by 6.022 into 10 to the power of 23. As both are cancelled together, we simplify that. We get here answer. Mass of 1 carbon atom is equal to 1.99 into 10 to the power of minus 23 gram. Look at children. This is very negligible, you know. It shows the negative exponent. Yes, this is very negligible amount of the carbon, one atom. Yes, now come to the second question. Which has more number of atoms? 100 gram of sodium or 100 gram of iron? Here atomic mass of sodium and iron is given. Now let us going to compare which is having more number of atoms, whether sodium or iron. Now let's calculate first sodium number. To calculate the number of atoms in 100 gram of sodium. Yes children, we know that molar mass of sodium is 23 gram. Molar mass of the sodium is 23 gram. That 23 gram of sodium contains 6.022 into 10 to the power of 23 atoms. Yes, now 1 gram of sodium contains, yes, do now cross multiplication, we get here 6.022 into 10 to the power of 23 divided by 23. Do now cross multiplication, 1 is multiplied with this much and 23 comes to the denominator. This indicates 1 gram of sodium containing atoms. Now come to 100 grams. 100 grams of sodium contains, this is multiplied with 100 you know. 1 gram it indicates this much. In the same way 100 grams is how much? 100 into this. Yes, now 100 into 6.022 into 10 to the power of 23 divided by 23. And now cancel together and we simplify that, we get here answer. Yes, we get here 100 gram of sodium contains 100 into this much. Yes, we simplified here, we get here 2.6182 into 10 to the power of 24 atoms. 24 atoms. Okay, now let's come to calculate number of atoms in 100 grams of sodium. 100 grams of iron. Sorry, here iron. Yes, 56 gram of iron. We know that children, molecular mass of iron is how much? 56 gram. Molar mass of the iron is 56 grams. 56 gram of iron contains 6.022 into 10 to the power of 23 atoms. Now let us calculate 1 gram of iron contains. Yes, 1 gram of iron contains, do now cross multiplication, here 1 is multiplied with this much and 56 comes to denominator. Yes, this number indicates 1 gram of iron containing atoms. Now let's come to 100 grams. 100 gram of iron contains is equal to 100 into this much. 100 into 6.022 into 10 to the power of 23. The divided by how much? 56. Now simplify this. We get answer 1.075 into 10 to the power of 24 atoms. 10 to the power of 24 atoms. As compare with 100 grams of sodium, 100 grams of sodium contains 2.6182 into 10 to the power of 24 atoms. But in 100 grams of iron contains 1.075. As compare these two, it is evident that 100 gram of sodium has more atoms when we compare with iron. Yes children, the chapter is clear now. The chapter is completed. As in this chapter we have been discussed about law of chemical combinations, atoms, molecule, molecular mass of an atom, molecular mass of element, how to write a chemical formula of the compound, formula, unit mass, molecular mass and mole concept, and so many in text problems. I hope that children, all of you understood very well. Thank you.